Okay, students, today we are going to see about solving n-queens problem using backtracking technique. This is your last lab program in analysis and design of algorithms lab. So how do we solve this? It uses the backtracking algorithm design technique. The idea is very simple. We are going to place queens one by one in different columns, starting from the leftmost column. When we place a queen in a column, we check for clashes with already placed queens. Start in the leftmost column. If all queens are placed, then return true. The third step is try all the rows in the current column. Do the following for every tried row. If the queen can be placed safely in this row, then mark this, that is row and column, as a part of the solution and recursively check if placing the queen can lead to a solution. Next, we are checking if placing the queen in row column leads to a solution, then we are going to return true. If placing queen does not lead to a solution, then unmark this row column, backtrack and go to step A to try other rows. If all rows have been tried and nothing worked, then you return false to trigger backtracking. The optimization actually lies in the save function. So we are going to have one save function. So the optimization of this algorithm is going to lie in this function. The idea is not to check every element in the right and the left diagonal. Instead, use the property of diagonals. You know that the sum of I and j is constant and unique for each right diagonal, where I is a row of element and j is a column of the element. So the difference of I and j is constant and unique for each left diagonal. So you are able to visualize the left diagonal. The left diagonal means it starts from left to right. The column, row and column number like 1, 1, 2, 2, 3, 3, 4, 4. So I and j will be same for the left to right, that is left diagonal. Okay, so we do the optimization in this function. Okay, before we get into the Python program, let me just show you a picture form of the chessboard. Okay, so if I am going to take a four queens, this 4 queens has to be placed in the 4x4 chessboard. So you are able to see the 4x4 chessboard here, and I want to place the 4 queens such that no 2 queens can be placed in the same row, same column or diagonal. So I start with the first queen. I try to place it here in the first row, first column. Visualize that it is placed. Okay. Now I pick up the second queen. I cannot place in the second row, first column, because it will lie in the same column of the first queen. So I move on to this. Here also I cannot place. So I'll place my second queen here. Now when I get into the third queen, what happens? Now you visualize that your first queen is in the first row, first column, and my second queen is in second row, third column. Now my third queen, I cannot place here because it will attack each other. I cannot place here because diagonally it will attack each other. Either I cannot place here, I cannot place here. So when there is no solution to place the third queen, what we have to do, we have to backtrack and change the position of the first queen, right? So first queen we have to place in the first row, second column, and then change the position. Earlier the position of the second queen was here, so change it to the second row, last column, and then now you can place the third queen here. Now if I want to look for the fourth queen, okay, so like this we have to proceed. Now this cannot be placed here, this cannot be placed here. So we have to look. We can place it here and then we end up with a solution. Now going back to the Python program. So when we get into the Python program, how I have written, I have three functions here. One is print solution of the board, and then so I have declared globally my value n is 4, and then what I do, we will start with the main function. So main function starts here. So solve NQ. So this solve NQ is a function which solves my n-queens problem using backtracking. So it mainly uses solve n util function to solve the problem. So in the solve NQ, what I am doing, I am initializing a list called board. So my chessboard of the list, I'm initializing the list called board. So in our case, it is a 4x4 chessboard. You can visualize. So initially, all the values are 0. That means no queens are placed in any of the rows or columns. Then I have a function. I'm going to check solve n. I'm going to call this function called solve n util. So if this function is going to return me false, then I print solution does not exist, and I will return false, else I print the solution. So now let us go to this function where we are passing two parameters. One is board and 0. So let us go to the function there. Now in solve n util function, we have passed board and column. Now there could be a scenario of a base case that if all queens are placed, then we have to return true. So how do I check that in Python? Right. So first we will see the definition of the function in Python. So always you have to use this def, and then solve n util is the name of the function, and these are the arguments. Now I have to check for the base case if all the queens are placed. So how do I check that? If column number, that is COL, is greater or equal to n, then I have traversed and I have finished off my task, then we have to return the true. Otherwise, we have to start with the process. That is, I have a for loop, and then I have a function which is called isSafe. So isSafe function will tell me whether I can place the queen, whether it is safe to place my queen in that particular row and column. Now I am calling this isSafe function. So isSafe function also will return me true or false. So your entire output will be in the form of a binary matrix, either 0 or 1. Either it is true or false. I'll show you the expected output later. Now I'm calling this isSafe function, and then this is going to have three parameters: board, I, and column. So let us get into that function, isSafe. In isSafe function, we are passing this. So now this is a function to check if a queen can be placed on that particular board of row and column. Okay, so we need to check isSafe. So from the name only we can understand that this function is called to check whether the queen can be safely placed so that they don't attack each other. So we need to check no two queens are placed in the same row, same column, and diagonal. So first checking is done. Check this row on the left side. So assume that you have placed the first queen in the first row and first column. Then we have to start checking this row on the left side. Okay. So I have a for loop for checking that for I in range of column. Then if board of row I is equal to 1. Okay. So if I have placed the first queen in the first row and first column, the second queen cannot be placed in the same row. So for that we are checking that. Next we check the upper diagonal on the left side. So how do I check that? For the upper diagonal as well as lower diagonal has to be checked. First I check the upper diagonal. This is the loop I am going to use. Right? And I have a condition if board of ij is equal to 1. right? Then I will return false. So whenever I say return false, that means in all these cases, in all these three cases, I cannot place the queen. Okay, so I have to check the upper diagonal as well as the lower diagonal, my left diagonal as well as the right diagonal. So as I've told you, we are doing optimization. So if it is a left diagonal, my row number and column number will be same. So that could be checked. And then I return false, means I cannot place the queen. Now check the lower diagonal on the left side. So that also can be checked. So what would be the value? So for that, to visualize, again we can go back and then see this chessboard. So what will be this value? 1, 1. This will be 1, 2. This will be 1, 3. This will be 1, 4. This is 2, 1, 2, 2. So if you see this, the left diagonal, all the values are 1, 1, 2, 2, 3, 3, 4, 4. So with that logic in mind, we are checking this. Okay, so we are checking the upper diagonal as well as the lower diagonal, and we are checking the corresponding row on the left side. So in all the cases, we cannot place the queen, so we will return false in all the cases. So if it doesn't fall under all these three cases, I have to return true. That means it is safe to place the queen. So I'll just come back. We'll come back to this function. If safe, if is safe, that means this function is returning true. Then I can place my queen that particular row and column. Board of I column is equal to 1. So there I can place the queen. Then again I am calling the solve n util function, right? So we need to place now the first queen. Actually checking that we have placed the first queen in the first row, first column. Okay, now we have to recursively call this function. Which function we have to call recursively? Solve n util has to be recursively called to check whether my other queens can be placed in the chessboard. So for that I am calling this function recursively, and if it returns true, I will return true value. Okay, so if placing a queen in the board does not lead to a solution, then I can make this everything as 0. So board of I column, I will make it as 0. So my expected output of this program, so I'll just come back to the main program, and then we had called solve n util function, and then in that we called eSave function, and finally what I'm supposed to do, print solution of the board. Okay, so finally I have to print the solution. Right, my solution will be in the form of a binary matrix. That means it will be in the form of zeros and ones, 0, 0, 1, 0, 1, 0, 0, 0. So if it is 0, 0, 1, 0, that means my first queen is placed in first row, third column. My second queen is placed in second row, first column, like that. Now third queen is placed in third row, fourth column, and my fourth queen is placed in fourth row, second column. So this is the expected output for 4 queens problem. So let us go to the Python environment. So same program what I have explained now, it is there here. So I am using Notepad++. So where I have written my Python program, right? So whatever I have told you, I have defined ns4 print solution of board. Okay, so print solution, when I called, it will just print the board, right? So finally, wherever you encounter 1, it will be the queen is placed. Okay, so print solution, when I call here in the main function, it is going to print my solution, right? Print solution is again one more function. So how many functions I have used? One is solve NQ, that is the main function which does the task of solving the n queens using backtracking. So in solve NQ, I am calling solve n util function. So in solve n util function, I am calling is safe, whether to place the queen. Then I'll just come back and I'm calling a function called print solution, where I am printing the where I have a for 2 loops I and j, and then I am printing the complete the 2 by 2 list I will print. Okay, so whenever the queen is placed, it is going to give me 1. If it is not placed, it is going to give me 0. So let us run this program. So now I have given 4. So you can see in my console, it is 0, 0, 1, 0 I got. Since I have globally declared my n value here as 4. So for 4 queens problem, the solution is 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0. Right? So that's it, students. So always n queens problems are multiples of 4. You could also try for 8 queens problem later. I mean, you can try giving the n as 8 and then see for what would be the output. Thank you, students.